Hi, I'm Trisha Radcliffe. Oops. I am a Docker captain, and I'm introducing Torben Pedersen. He leads the IT architecture team at Halliburton, and he's going to share the customer story of digital transformation readiness, the Docker journey at Halliburton.
All right.
All right, cool.
Thank you, Tricia. You guys can hear me okay? So I appreciate you guys being here, especially after a robot demo. I'm not sure I'm going to be able to top that one, just setting expectations up front. No, I appreciate you guys attending and also for Docker for having us. This is a readiness transformation for Halliburton, meaning that we are in the journey, but I wouldn't say we're done with the journey. So it's still something that's ongoing, but happy to share kind of what we've learned through that process. I also think it's an opportune time to talk about transformation, particularly at Halliburton, because we are a 100-year company this year. And to stay competitive and in the business for 100 years, we see transformation ongoing all the time. And that means we have both greenfield and brownfield solutions that we need to account for as part of that journey. So let's talk about the agenda real quick. Oops, am I up? There we go. We'll do a quick overview, kind of what Halliburton is, who we are, what we do, and then talk about our distributed computing platform that's really a catalyst to why we're looking at Docker. Talking a bit about how and why we chose Docker as part of the solution aspect, and then really get to the meat of our journey itself, kind of going into what was easy, hard, and kind of difficult for us along the way. A little bit about me. I'm Torben Pedersen. I call Houston, Texas home. I'm originally from Denmark, but been in Houston for 20 plus years now. Been an enterprise architect with Halliburton for a little over 5 years. I have a great team in Houston where we focus around business outcome-driven solutions to our business units. Prior to that, I was 14 years with Microsoft. For a little bit about personal life, I do enjoy camping. I have 2 wonderful children. And my wife go camping quite often. In Texas, we got to have Texas barbecue, so I had to learn about barbecuing there. And then I do some gardening in the leisure time as well. A little bit about Halliburton. We have a global footprint. We have about 50,000 employees globally. We got about 80 plus countries that we operate in with 16 research centers. And from a headquarters perspective, we actually have 2 with corporate headquarters in Houston, but we have a secondary headquarters in Dubai as well. Our research centers is really around innovation and technology. That can be both from a digital perspective, but also from an equipment. We do manufacturing, as well as chemicals and everything else we do to supply our services. So what is Halliburton itself? So we're essentially an oilfield services company, and what that means is that we collaborate and we engineer solutions to maximize asset value for our customers. And our customers essentially are the ones that are producing the oil and gas throughout the life cycle of the well itself. So we have services that span the entire life cycle. Most people are usually familiar with drilling. That's one of the particular services that we perform. But from a Halliburton perspective, there's actually 14 business units. We call them product service lines. Drilling is one of them. We have others that focus around drill bits. We have others that focus around cementing and so forth. So different service lines focused around different core competencies. We also have a service line that's completely digital. Landmark is one of the areas that is commercial software for us, but it is also a product service line around selling software to our customers, just as we do traditional services. So from a computing platform perspective, we really structured around the 4 main pillars around edge, mobile, cloud, and then our data centers. And when we talk about edge, our definition of edge is it's both OT and IT, and now with the combination of OIT from that perspective. And that means that some of those edge computing can be short-lived, meaning if we go on location, if we go to a field site, whether that be on land or offshore, the location longevity on the edge can be as few as a few hours, but it can also be as long as days or weeks, depending on the service line that we perform. That presents some interesting opportunities, particularly for around how we provide digital compute to those its locations, and also how do we demobilize and bring it back again. We also have more long-lived locations. So Halliburton has manufacturing facilities around different locations, and those are really what we consider more the stationary and static environments that we have to deal with. From a mobility perspective, our mobile workers, that can be anywhere from our business development groups to other support functions or business units that are just mobile in their day-to-day work. It can be on locations, it can be remote from the office. But we kind of separate out mobility from the edge itself because it's more of an IT-focused area for us. And then cloud. We're not all in on cloud. We're not necessarily cloud first either. Really what we're doing is we're doing around workload optimization, which means we're hybrid. We will put the workload in the cloud if it's best suited in the cloud, or we'll put it in our data centers if it's best suited in our data centers. So we really need to support both options there and find out how do we present the compute to our business units regardless of where it sits. It's usually a latency issue, particularly when we talk about global thing of where the compute sits, and the cloud gives us some freedom and elasticity to kind of provide that global scale. So where does containers fit in? If we take mobility aside and really focus around the edge, the data center, and the cloud as around where containerization can help us, we started out with an architectural vision. One part of it was portability. That was the first thing that we really drove us to containerization in the first place. We knew we wanted to be certain pieces in the cloud and be elastic, but we also wanted portability. What if we ran a certain model in the cloud, but we now wanted to run the same model at the edge? What if that compute had to sit in the data center? We deal with data sovereignty rules every so often where some things can't leave a certain proximity or country, in which case now we need to stand up compute and infrastructure in those environments. So what really appealed to us from a containerization perspective was this notion around having that centralized management from a Docker registry perspective, using Docker Enterprise, and then provide the distribution mechanism to the edge, to the cloud, and the data center, while still having security built into it at that point. And that gives also a capability for our different business unit from an application development perspective to contribute and share off of that general repository itself. Beyond just source code sharing, now we have binary and really the immutable aspect of having that image to be non-changeable and have others extend off of it. And we do have certain service line that has cross development collaboration where one will build a baseline, the other one will kind of build on top of it from that perspective. So the integration for Docker Enterprise, at a high level, we divided into sources and targets, and really back to the centralization, having the DTR kind of being the broker mechanism for that. Where we have the sources come from can be from the business lines. It can be from the support function that builds line of business application. They will contribute images into our DTR itself. They have to come from some images, which is where we look to the Docker Hub, or commercially from third parties providing those certified and validated images that we can extend on. I spoke a little bit about our digital product service line, Landmark. They also have containers. They also build containers, but they build them as part of their product, just as a different service line would build a drill bit as an example. But we want to leverage that product. We want to be our own customers of those solutions as well, so we can bring in from their repositories into the internal systems and have other line of businesses reuse those applications that are being built there. And that gives us kind of that centralized clearinghouse where we can scan the images, we can verify that they've been trusted, and then tag as to what is ready for production. And from there, then define what's the target. Is it the edge runtime that we want to target into? Is it a traditional IaaS infrastructure? We run Docker Enterprise in our IaaS environment today for both the DTR as well as for worker nodes itself. Or can it be a data center runtime? If we have something that either based on data sovereignty needs to be in a colo, or it's in our own data centers, we now have the capability to set that up. And then last but not least is really the cloud service providers. There's been a long evolution, or actually short evolution, but fast evolution between the cloud services providers around what do they offer up in the container space. And the Kubernetes managed service is something we want to be able to offer up to our service lines as runtime compute capabilities as well, and have them integrated in from that central distribution point. So where we started from a journey, before our first use case, we looked at Docker back in 2014. We did have a data center use case at that time that would have been advantageous to put Docker on, but the technology was not mature, it was not ready for us. Traditionally, Halliburton is not a bleeding edge or cutting edge adopter. We try to be fast followers, so once the technology really has gained traction, that's when we usually try and adopt it. So spring forward to kind of 2017 era, we had a different use case, and that was really where we started looking at the edge and having Docker be the solution and the platform that could distribute our application centrally to the edge. So we started off with a Docker trusted registry and build a governance model behind that, and then really make it available for an edge runtime deployment. The data center, based on the integration we did in IaaS with DTR, we now had an environment that was ready. If there was a business case or a need to set it up in the data center, we would be able to do that, but it wasn't deployed. We do have environments in the cloud now from an IaaS perspective to build out the worker nodes for back-end data center applications, but that's not where we started at that point. And then the last marker that we're looking at, some good announcement with Docker Enterprise 3.0, such as the managed service is definitely something we want to look at, but also federation is the thing we very much are keen to have more work happening in, so we can collaborate and federate into other hosting providers, and particularly the cloud service providers with their Kubernetes services. All right, so that was a little bit of background about Halliburton and kind of where we were from a Docker perspective. So let's talk about the journey, kind of the easy, hard, and the difficult part. So the easy part is really the developer buying it. Just, if you don't mind, from a show of hands, how many are developers in here? Okay, excellent. And all right, so I think the developers will gravitate and understand Docker better than anybody, because from a development perspective, it's really around how do I use the tool and the craft that I've honed based on my experience as a developer itself. And Docker really opens up that freedom. We talked about 14 different business lines, and the engineering, even at a software perspective, is sitting closer to the business in many different cases. And that means from an IT perspective, if we have to support different kernels, whether that be Windows or Linux, different development language, whether that be Java, .NET, C++, still some Fortran out there in certain cases, and so forth. We need to be open to that, particularly from an IT perspective, because it's around getting that business problem solved. And the containerization provides that nice abstraction layer for us to really give the tool chain choice back into the developer, not have them constrained from what can IT support. Now, we still have to manage that of saying, well, how much is the manageability overhead from an IT perspective? And that's where the abstraction layer really helps us. And portability is one of the areas we spoke as well. That was key for us to be able to run certain models, particularly when we talk about analytics, test the analytics out in the cloud, and then move it to the edge at that point. Another area we ran into was the IT leadership, and that buy-in also turned out to be easier than anticipated. And it's because from an IT perspective, it's not always about day one. Day two is just as important to focus on. And so having an ease of deployment and also an ease of patching and update really resonated from a leadership perspective that really was grounded in around being able to start off with a use case. So the pilot project needed to be identified back to, we can't just get ready for every possible scenario out there. So when we had the edge solution in place, we had both a workload and we had a fairly low entry cost to get started around setting up the registry and the edge computing to be able to deploy out to. From a hard perspective, let's move to the hard. Showing business value became a little bit harder. When we start talking to the business around Docker, the first thing they're going to ask is, well, what's in it for me? What's it going to look different to me? What's the new feature? What are the things that are going to do differently? And if we just take an application, containerize it, and say, here it is, in transparency, this is Halliburton.com. It's not containerized, but if we did and we showed it to the business, it would look the same. And they're asked back to us, well, why would I invest in it? Why would I spend time on it? Why would I spend money on it if I don't see anything different? So we really had to talk about more indirect benefits and the non-functional areas that Docker brings in. And that was around the centralized distribution. As we mobilize and demobilize, a lot based on the services we perform, we continuously have to update and manage the deployment. Doing that centrally gives much more consistency in what pieces of software gets deployed out to the different service lines themselves. A key metric that we always measure ourselves on is something called non-productive time. Our drive is always to have 0 non-productive time at the rig. And that's a key element of saying change introduce risk, and that risk can introduce non-productive time. So from a containerization perspective of saying, how do we modularize change and how do we make change smaller so we reduce the risk of change, was the key driver for that, to talk to the business about, more in the terms of non-productive times than in terms of, will you modularize your code? We have to kind of cross that barrier for translating the benefit out. And then the last piece was around increased support for side-by-side execution. We are brownfield. We have many years of software still deployed out there. Some of the challenges we have is the infrastructure we can't bring to the edge. Some of it we don't have the ability to bring a whole mobile data center in, so we have to make do with the compute we have. Some applications have compatibility issues. Some of you are probably familiar with it based on whether it's a Java runtime, a .NET runtime, whether it's a DLL versioning or anything like that we often solve by having redundant compute solutions in. Containerization now allows us to take those legacy applications, even if they are incompatible to run side by side, and have the density on that single compute system itself. And from a translation back to the business value, it's really around lowering their cost for IT. If they need to buy new hardware, that's usually a detractor. If they can reuse their hardware but still get value of it, that's usually what they're after. And then let's talk about platform adjustments. A little bit back from a developer perspective itself. We had to think about Docker differently than our traditional OSs, whether they were virtual machines or physical machines, particularly when it came to the persistence layer. Keeping state in containers, possible. Managing state in containers, particularly if they become short-lived, proved challenging for us. It was easier for us to contain and stay with the brownfield persistence layers we had in there, whether those were standard databases or whether those were PaaS services, and just use the more stateless services, the web front ends or the application tiers that didn't have the state requirements, go to containerization and keeping the rest on the traditional databases. And then orchestrating the orchestrator. Back to the brownfield, we had certain investment already made into parallel computing. Apache Storm is one of the technologies that we're using for parallelization of workloads, and that comes with a built-in orchestrator. Well, we tempted to see, should we orchestrate the orchestrator? Should we take Zookeeper and everything else that sits behind Storm, put it in Docker, and now we have an orchestrator abstracted by another one? Possible. Not easy. It was hard. And really what we came out of that exercise from was to say, it's probably better off leaving it in Storm if already has an orchestration model in place where we can fan out. But if we do containerize it, take the workloads that the Storm is doing itself, put that into essentially the Docker orchestrator, whether that be Swarm or Kubernetes, and let it control it at that point. Doing both on top of each other was a little bit more difficult than we could take on. The other piece around orchestration was picking the right orchestrator. When we started out looking at orchestration, we were always talking about the Betamax. So if any of you remember the Betamax days versus the VA6 days, we didn't want to pick the Betamax. And that was really challenging because we had Swarm out there, we had Kubernetes out there, we had Mises out there, we had Warden or Garden from Pivotal and so forth. There's so many different orchestration tools out there. Which one should we go with? And we chose to stay native. We chose to stay close to Docker itself and lead with Swarm. One of the key areas that Swarm provided for us was back to the tool choice, and particularly the kernel choice, to be able to intermix both Windows and Linux-based kernels, and Swarm was really the first orchestrator out there that was able to provide us that capability. As the industry progressed over the last couple of years, Kubernetes certainly coming out there as the front runner from an orchestration perspective. But the nice thing that has kind of evolved itself in there is that not only has Kubernetes gained support for Windows, but also Docker has embraced it at that point. So we feel that whether we do Swarm or Kubernetes, we can make the orchestrator really a tool choice from the development team based on what dependencies they have on that. And then the secure computing itself. Secure computing is really important for us all the way through of all the tiers itself. And it's different, again, when it comes to containerization. From a security perspective, our first inclination is we got to take our traditional endpoint security, our vulnerability management tools and everything like that, and sit it into the containers. So having Docker Enterprise manage the images, do the security scanning of that images, let us vet out what is ready for production, what's been vetted out from a security perspective was crucial. And Docker Enterprise allowed us to help in that regard. Process adjustments. So testing now suddenly had a change in process, particularly because of increased churn. The increased churn came in two pieces. First was because we started at the edge, and at that time the edge was not that mature. We knew we were early in from an adoption perspective, and we kind of had to hedge our risk a little bit. So we chose to build our output not just as containers, but also as traditional MSI installers at that point, which meant the testing team all of a sudden had two applications every time there was a build to go through from a testing process. So where we had areas of manual testing before, we really needed automated testing in order to keep up from that perspective. The other piece was when we had regression testing or system testing. Traditionally, if it was a full MSI package installer, finding out the module that had changed and really go deep from a regression perspective in that module versus the integration testing across the whole system was challenging. With containers, now we have the option and really have ability to change that process out and make sure that if we modularize the change into a specific module, we can get very deep regression focus on just that model and just focus around the outside of where the system integration has to sit there. That also helps us from an edge perspective. And back to the business, we heard this morning the business all about going fast. We feel the same thing from IT. I can't get it fast enough, right? So, but with that speed still comes the need to make sure that it is tested and verified and ready, particularly in the OT environment. And containerization, again, gives us that opportunity to really get small and focused around where the change is to minimize the risk. And the last piece around process adjustments are really moving away from gold images. Traditionally, everything we had done prior to containerization, particularly in the VM world, and we're still there today, is we use gold images, and we use that as a foundation for the application team to build on. What Docker has moved us toward, and where we're also moving towards even from a virtual machine perspective and physical, is really configuration over image configuration. So start off with those blank images, whether they're marketplace provided, whether they're hub provided, where they come from, and then configure the necessary security, hardening, application, and everything else in there once the actual OS has been laid down, or in the case of Docker, once the image has been created. Another hard one, operational impact. So from an IT perspective, again, is when we deploy Docker out, where does it live? And every organization is structured a little bit different, but from an operation perspective, our two primary, at least from an infrastructure and application, lives with two different teams and two different groups. So where should we deploy Docker Enterprise? We actually started out doing it at the upper layer of the dashed line. It started out in our application services group, just because that application group was closest to learning about the containerization, what it meant, but now they suddenly took on a lot of infrastructure they had to know. Docker is different. They suddenly have to know about network load balancing. They have to know about virtual networks, overlay networks. What's the implications around having those different images talk to each other and the isolation levels? So we put a lot of burden on the applications team that we're now trying to push upward. So kind of move the line up and get the Docker engine itself closer down into the infrastructure group. So from a readiness perspective, whether the infrastructure group is being asked for a physical machine, a virtual machine, or a Docker runtime environment, it can be provided as that general compute platform, and then bring the actual application development back into just the application group themselves at that point. And then onto a couple of really difficult things. This first one actually had nothing to do with Docker, but it changed how we perceive the value of Docker itself, and that's really around modern application design. We saw the acronym earlier around cloud native application, and that's really critical for us to get the most value. If we have monolithic application, containerize them, and we went through some of the modernizing traditional applications as well, and could get it up and running, that wasn't really the difficult part, and it gave some level of isolation and portability around the application, but it didn't give us the orchestration benefit. It didn't give us the scale benefit. So trying to change that adoption process into more distributed compute model is something that the teams really need to be ready for before they join, and that goes in whether that's Docker or any type of distributed computing, but that's really from a Docker perspective, that's where we see we will get the most values. So we need to make sure that small is better, and small is not just around the packaging and the microservices, it's also around our transaction handling. How do we ensure that we're not having long, heavy running transactions, but we really let these services come up rapidly and then dispose of the request as much as possible. And then also the readiness of the state management. Where does state reside? Now the state is suddenly transitioned across potentially many different containers or the nodes themselves. When we start troubleshooting, where do we find where things went wrong? And that's particularly from an operational perspective. The first thing is, where did it fail? Log management, again, not a Docker-specific element, but it was a critical predecessor for us, is that we need a strong log management solution and really identify where systems are interacting with each other along the way. And then predicting the future. That became very difficult, and we took some big bets based on the timing of when we came in there. Side-by-side support for Windows and Linux kernel wasn't available at the time. We could run Windows and Linux kernels on the same machine, but it required essentially a Linux VM inside of the Windows OS. We were happy we took a bet on that, because now that we have the Linux kit available, we're now getting closer to fulfilling that desire where we don't want the developer to worry about what OS they're running on. We can provide support for either kernel. The edge itself for us is also Windows-based, back to kind of what are the deployments already sitting in the field. We had a very heavy Windows deployment out there, and as that was moving to Windows 10, it gave us the option to bring in containers, but it also brought with it some constraints early on, particularly around the process isolation mode. So where Windows 10 was at that start was really Hyper-V containerization, where we essentially get a virtual VM per container that we spin up. The challenge that gives us is we now have a high demand on physical memory, and we see this VMM process essentially spin up per container, which means on average they were around 200 megabytes, even for something fairly small, that we would quickly drain the machine of memory for just running the container itself. That essentially meant we had to reduce the number of containers we ran at the edge in order to make sure our memory management was there. Now with process isolation also coming to Windows 10, it opens up our opportunity to really get much smaller, even at the edge from a containerization perspective. And then the last piece was, where did the cloud service providers go with Docker, and how did Docker Enterprise fit in with the cloud service provider? That is still an ongoing journey for us. We're still hoping Federation can kind of help us in that area. So in closing, the last thing I think I want to hit on is what was really, really difficult, and that's culture itself. Just like DevOps, I'm sure many of you who's already dipped into the DevOps model around how do we do Agile faster, both on the dev and the ops side. Containerization itself is a culture change. It's not just a technical understanding how it works and getting up to speed. It's also a whole new way of how do we develop, how do we troubleshoot, how do we operate, how do we support it, that there has to be a culture change that really flows not just within one group, but it's every group, is from the application to the infrastructure group, and then it's the impact back to the business. Does the business know when you're changing and how frequently you're changing too? So we're still going through that culture change ourselves around how do we really introduce speed. The business is asking for speed, but do we have a culture that really can accept it as well? From a containerization perspective, the change agent for us, where it comes out the most, is the developers. The developers are the ones who really sees the benefit, and that's where we want to turn more of those developers into also teachers and kind of help educate the rest of the organization of here's why this technology is more than just a development tool. It's really around providing value back to the business and the outcome that we're after. With that, I think we have a few minutes left for questions. Yeah.
What tools do you use to secure the environment in very interesting development technologies as well?
Okay, so the question is what tools we use for securing the environment and then also our log management solution around that. For securing the environment, we are still using, from a node perspective, we're still using traditional malware protection. We have talked to our antivirus provider. They have added additional support or current support, in particular for Linux node, to actually scan the containers themselves. We have not deployed that yet. We're still evaluating that to determine the impact. It's from a Windows perspective, we haven't found the tool yet on that side that can do that. So we're really looking for how do we secure the host with the traditional endpoint protection, offloading kind of the images and the containers as a non-scanned location, and then hardening in the image themselves. So there's still a risk there, and we're hoping from the vendor's perspective they can help provide a solution in that space. We know they have some on the Linux side, still evaluating it, figure out what the solution is for the Windows containers. For the log management, so we're a Splunk customer. We use Splunk for our log aggregation. So it's really around putting the right level of troubleshooting and not forward everything to Splunk, really what is the critical element. And then it's around particularly our transaction flow. Do we have correlation IDs through the system as the messages flow, and then we forward it onto Splunk for aggregation and visualization.
You said you're kind of halfway through. How are you measuring that, and are there any kind of metrics that you could share?
Yeah, so how do we measure the culture from an adoption perspective? Yeah, so that's one, quite honestly, I don't think we're doing a great job of measuring. I think the biggest measure we have is really around adoption from a platform perspective. Again, from an IT side, we'll see the demand come in from the business around it, and that's really the uptick of seeing what business units are looking at it. There are some that are much further ahead than others. And back to our all digital product service line, like our Landmark group, their culture has completely shifted over. They're very much container first driven in their solutions. So their culture has changed, but that's just one business line within our company. From changing all the other business lines, they may not have the same drivers or need to change as rapidly as a software service. So we're looking at what applications are they containerizing in, and it's picking up, but the actual metrics and measuring it, I would say it's based on application we have deployed, and it's not high at this point.
So again, on security, I think you said you have your developers build Docker images. Do you have CI/CD around that, building the Docker image and creating the image? And if you do you have a security scan that will scan the Docker file to make sure that I'm not opening root access or things like that?
Right. So our secure development lifecycle around containers and our developing the images and deploying at that part. Yeah, so our SDLC process that we have for any traditional applications is really geared around the programming languages and what they're developing out there. So that carries over even from a Docker perspective. So the normal application SDLC, we're using that even for the container deployment around building those best practices in there. From an image creation, this is where the DTR is important for us from a Docker enterprise perspective, because it has that image scanning built into it, and that gives us another layer of security on there. We're still looking at post-deployment, right? Back to the conversation earlier around how do we secure it once it's deployed. That's an opportunity that beyond just the node, how do we provide the container security? We're looking very much to our supplier community to help us address that area there.
And do you have access open to Docker Hub, or how do you manage that? Or you close that access?
To the software development hub?
To Docker Hub.
To Docker Hub, yes. So at present, everyone has access to the hub. What we're looking for is mirroring. So we're mirroring right now the base images that we vetted out from an IT perspective and security has looked at. So anything that's Docker certified, so the traditional Linux and OS kernels that we know we can build images off of, those are mirrored into our registry, and that's where the development team should be structuring their releases off of at that point. So that's the biggest area where we're really looking for that centralized management. Like most IT organization, if there is a level of standardization, we need centralization around managing that. And if we let the developers move out to every repository where they find images, we lose the standardization of management. So the DTR is critical for us in that area. Yep, back there.
Do you also have standardization of the deployment side of that from DTR to each one of the individual targets you talked about, from like edge and cloud and data center? Is that a standardized deployment strategy as well?
Yeah, so let's talk about the edge from the DTR to the edge. So we've done, again, based on our adoption, there wasn't really an edge standard at the time. We had to build that in there. We used our solution integrators to come up with a solution based on what they already had prepackaged before and then what they extended into our environment. And that essentially was an edge runtime that had a manifest service where they could go access what should that edge look like. A lot of acronyms are out there. People call it the device twin and so forth, right? But it was the same concept, right, where the edge would have essentially a central repository where they report it up and say, here's my current state. And if we change that state from a manifest perspective, the agent on the client edge would go to the DTR to pull up the application updates at that point. From a data center perspective, in the DTR, if it's the DTR worker nodes, that's where we do the distribution in. When it comes to the cloud, the managed cloud services, orchestrations like the Kubernetes, AKS, EKS, or OKE, that's really where we're hoping Federation will provide that centralized management in there. It's still a little bit of a manual pull at this point than it is centrally managed.
Okay, thank you.
Oh, over there.
This is my exercise.
Kind of follow on to the earlier question over there. You mentioned in the talk about moving from like gold images to images, adding like certain configurations for those images. Can you kind of add to that? Like what type of configurations are you like adding to like your base images? Yeah,
so that's kind of the global images versus configuration of images. It stems really from the virtual machine world, right? Where if we had an OS, whether it be a Windows or Linux OS, we would create a base image, meaning we would ensure all our security tool, vulnerability, antivirus systems, and everything was already pre-packaged on there, right? And then the application team would lay their application on. What we're doing, the same thing from a Docker perspective, now with Docker, what we're looking at is instead of us creating a Halliburton Docker image, let's say it's a VM or a kernel that's Windows-based, right, where we put some extra sauce on top of what the provider provided, we would have to now manage that particular image. Every time that the provider changed the underlying base image on us, from an IT perspective, we would now have to manage whatever configuration we put on top of it. That image management, whether it's containers or either in the VM world, becomes very challenging, particularly from an operational perspective, because we're now at the mercy of when the provider who created the gold image or their gold image, whenever that becomes available, we have to take it in, put our own things on top of it, and then release it to the application developers. And the developers, and I've been one of them, so I understand, is when they see some new feature out there, they want to grab it, right? And they say, well, I need the latest version of Windows or this particular version of Linux. And if IT is sitting in between there for them to adopt it and slow them down because we have to create our own gold image, we're slowing it down. We're slowing the process down. So the switch that we're making there is, instead of having us, from an IT perspective, create that extra layer, we will put the configuration into whatever the provider gave us. And that way the developer really is able to pull in the image from the raw nature. We put the configuration in that our gold image would have done previously and still secure it and have all the controls in place. But from a process perspective, it gets it to the developers faster.
One more question?
Okay.
Yeah, thanks. Thanks for presenting today. Appreciate it. Just take it up a higher level. And I apologize, I was here a little bit late, but what led you to Docker? And what other PaaS platforms or container platforms were you looking at? And kind of what were the differentiators that really stood out for you to guys, all right, we're going to go build behind this, this company and their technology?
Yeah. No, that's a great question. All right. So we've talked about how do we provide applications faster? And we've looked at lots of application platforms, particularly from the cloud service provider, right? Whether it's PaaS or whether it's no-code platforms. I'm sure you guys know all the vendors out there in that space, right? And the challenge, there's good and bad with those platforms. The goodness is it is fast and it is rapid, but once you learn the technology, we can do things very quickly. The challenge from us is the flexibility of choice, is really what it comes down to, is that if for some reason we now need to move to another platform provider, how much of our logic and business process is tied up with that provider and how sticky does it become? That's been one of the biggest challenges for us to adopt pure on PaaS services, because once we're in there, yeah, we may build it fast, but we're not going to get it out fast. And that's really where we say, from a containerization perspective, where we can abstract all of that back and really use the cloud services as the hosting provider, it gives us that portability. That was the main driver to say, why don't we just go all PaaS? It doesn't mean we don't use PaaS. We absolutely use PaaS, but particularly when it comes to the edge, even the cloud service provider and the Amazons, the Microsofts, and others have started to shift more, both from the cloud and also from a physical perspective, that at some point it may become mute to say we can't run it in the cloud, whether it's local in our data centers or locations, or if it's in their hosted data centers. But at the time when we went in, Docker seemed like the right fit for that scenario. Was that another question?
If you want to do one more, but it's...
Oh, we're over. Yep. Okay.
All right.
All right.
Thank you
Well,
all.
thank you all. Appreciate you coming.